Hello everyone. In this session of CCNA series, I will discuss about congestion avoidance. Congestion avoidance, also known as CA, is a QoS mechanism used to reduce the overall packet loss by preemptively discarding some packets used in TCP connections. To understand how it does, we need to first understand how TCP windowing works. TCP uses a flow control mechanism called windowing, where each TCP receiver grants a window to the sender. So in TCP, the window refers to the amount of data, that is in bytes, that can be sent by one side of the connection before it needs an acknowledgement from the other side. It is like a buffer that holds data waiting to be sent or acknowledged. So window size can vary based on the acknowledgement. So TCP windowing allows the sender to adjust the amount of data based on, data sent based on the receiver's ability to process it, which means the receiver controls the sender's rate of sending the data. As you can see in the figure, A is the sender, B is the receiver. You can see the window size increasing, right? So TCP windowing allows, as I said, the receiver controls the sender's rate of sending data. If the loss is detected by the receiver, TCP uh, shrinks the window size. So that is one of the advantages. So let's discuss about the router queues for a moment. Because without a congestion avoidance tool, an event called tail drop causes the most drops in a network. When with little congestion, you will not see any drops, as the queues are not full. But when the queues start to fill, and if it is full, it will drop the packet at the tail of the queue. As many queues are congested, the more drops will occur. So the more congestion, the bigger the negative impact on traffic, both in terms of loss and in terms of increasing delay in TCP connection. So congestion avoidant tools use TCP's windowing feature to minimize congestion. As I said, it uses windowing feature, TCP windowing features to minimize the congestion. So these tools discard some TCP segment before the queues fill, hoping that enough TCP connection will slow down, reducing congestion and avoiding packets being dropped due to tail drop. It monitors the average queue depth over the time. So the height of the box represents the queue depth. So when the queue depth is below the minimum threshold value, like shown in the yellow, it does not react. Okay, and when it is between the minimum and maximum threshold, the congestion avoidance tool discards a percentage of packets. When it is in the middle, between minimum and maximum, it discards a percentage of packet, usually a small percentage like 5, 10 or 20%. But if it crosses the maximum threshold, when you see the orange one, uh, the tool drops all the packets in an action called full drop. So like in other QoS tool, packet with one marking might be dropped more aggressively than those with a better DSCP marking. That means uh, earlier we have studied about different DSCP marking. So whichever marking gets better value, the drop priority will be less. So the lower priority will have higher drop. I guess that's it for this session, and that's it for this IP services chapter. Thank you for watching. Please let me know if you have any queries. I would like to help you guys.